simplify these complex fractions with variables in them. Rational expressions, we would call these. Okay, my favorite way to reduce these or to simplify them is to multiply through by the least common denominator of both the top and the bottom. So I'm going to put big parentheses around this, and notice that the least common denominator is going to be 36y squared. So I'm multiplying 36y squared against the top and the bottom. In the first case, the 36's cancel, so you'd be left with a y squared. In the second case, the y squareds cancel, so you'd be left with a 36. In the denominator, in the first case, the 6 reduces, so you'd be left with 6y squared. And then in the second case, one of the y's reduces, so you'd be left with plus 36y. Notice how it's already taken the fractions of fractions and just turned them into fractions. Not done yet though, we should do some simplification. The numerator happens to be a difference of squares, so I'm going to go y plus 6, y minus 6. The denominator has a common 6y that can be factored out, so I'm going to do so. And after I've done that and gotten my y plus 6 left over, I can see some additional simplification. So the final answer to this problem after full simplification would be y minus 6 on top and 6 multiplied by y on the bottom. Let's try another one. 1 minus x plus 3 over 5x minus 5 over 1 minus 1 over x minus 1. Okay, so again I'm going to multiply by the least common denominator of the tops and the bottoms. The 5x minus 5, pretty sneaky here, I'm going to think of that as a 5 times an x minus 1. I always like to factor first because it's going to help me to find my denominators. Okay, so on the top and the bottom we're going to multiply by 5 times x minus 1. 5 times x minus 1. By doing so, in the numerator, 1 times 5x minus 1 is 5 times x minus 1 minus 5 and x minus 1 both reduce, so all we have is an x plus 3 over 1 times 5x minus 1 is again 5x minus 1, and this time the x minus 1 reduces, but we still have the number 5. So again, losing some of the fractions should make it a little bit easier to digest. Now in the numerator, looks like we have a 5x minus a 5 minus an x minus a 3 over 5x minus 5 minus 5. Collect like terms, 5x minus x would be 4x. Minus 5 minus 3 would be minus 8 over 5x minus 5 would be minus 10. Ooh, and I can see some common things I can pull out now. Looks like a 4 times an x minus a 2 over a 5 times an x minus 2. Ha, so isn't that wonderful? It looks like the final answer to this problem is actually 4/5. Okay, why don't you pause the video if you haven't tried one on your own already and try to do this one. Assuming you gave it a good old shot here, what are we going to multiply top and bottom by? Hopefully 25x squared was your choice, because if you do so, you would get in the top 5x squared plus, looks like 25 on an x. And what do we get in the bottom? Looks like the 25's will cancel, so we get a 9x squared, and then minus a nice little 25. All right, looks like that's what we're getting on the top. Or, sorry, that one is on the bottom. Okay, so numerator, factor out 5 and x, left with x plus 5. Bottom, difference of squares, looks like a 3x plus 5. And a 3x minus 5. Unfortunately, I don't see any more simplification I can do there, so I guess we just gotta stop and put a box around it and a smiley face.